Hello, this is Helen Thomas and the CDFM study group. I'm going to be covering CDFM Module 4, Competency 2, Systems Engineering topic. This is out of the 2011 study guide. Again, this is Module 4, Competency 2, Systems Engineering out of the 2011 study guide. All right, let's see what we got going on here. All right, so system engineering defined. Systems engineering as applied to defense acquisition is the overarching process that a program team applies to transition from a stated capability need to an operationally effective, sustainable, effective system. So systems engineering is now taking that capability gap that we identified in the JSIDs, and we're taking it from a need to actuality. When we have an operational product to be able to meet that need, that's all. That whole process is called systems engineering. So I'm on page 4.2.2 within that paragraph, systems engineering defined. I have some check marks. So the system engineering process are applied early in the concept definition and then continuously throughout the life cycle, the total life cycle of that product. So you identify the capability need. If it's a material solution, we know it triggers the acquisition system. And then from that capability need to an operational product, then we call that systems engineering. All right, let's move on to page 4.2.3. Talks about the systems engineering plan. We have a need, we have a capability gap. Now we have a plan in how we're going to meet and fill that gap. So the systems engineering process. The system engineering across the systems life cycle is a rigorous system engineering discipline necessary to ensure that the Department of Defense meets the challenges. Okay, so that's just a lot of words. Let's go down to the second paragraph. Systems engineering plan. The program managers. So when in doubt, pick program managers, right? Program managers prepare a SEP, systems engineering plan, when for each milestone review, beginning with milestone A. So a systems engineering plan is produced at each milestone decision review, beginning with milestone A. So at milestone A, the SEP supports the technology development strategy, and at milestone B, the SEP supports the acquisition. And just kind of remember when we went through the phases and the milestone. So milestone A, when we're starting off that technology review and technology strategy, that's the purpose of the SEP in milestone A. It is to support the technology development strategy. And then when you actually go into a full-fledged acquisition system in milestone B, that SEP supports the acquisition strategy. So two different types of SEP in the paragraph under SEP on page 4.2.3. All right, what else it says? The SEP describes the program's overall technical approach, including key technical, so technology, technical approach, technical risk, processes, resources, metrics, and incentives. It also details the timing, conduct, and success criteria. All right, so the key things I got out of this, let's see, it is embedded in program management. Systems engineering is typically implemented through multidisciplinary teams of subject matter experts, those IPTs, integrated product teams, and through the systems engineering working plan. All right, so we got that. SEP, introduce, milestone review, starting at milestone A. The SEP in milestone A is for technology, technology strategy, and the SEP in milestone B is for the acquisition strategy. All right, got that. Page 4, what do I have? Configuration management. The program manager should use a configuration management approach to establish and control product attributes and technical baseline across the total system. The approach should identify, document, audit, and control the functional and physical characteristics of the system design. Okay, I was just reading it because I had a check mark next to it. So, page 424, configuration management. Page 425 talks about the modular open systems approach. Again, if you think of the acquisition system, it's not always starting from scratch with a brand new product. It can be a modular system where you could take pieces of it, you already have a portion of it, and you just adjust it through technology or whatever to make it fit what you need. So let's see. Data item unique identification. The DMS, the data maintenance system, will be approved in the context of the acquisition strategy prior to issuing a contract solicitation. Item unique identification, that's the tail number. Electromagnetic spectrum supportability. So you're developing systems, what type of system or impact. For all electromagnetic spectrum system, the program manager shall comply with the U.S. and host nation spectrum regulation. They shall submit written determinations to the DoD component, the Chief Information Officer, or the equivalent. All right, so, okay. Lots of information. All right, page 4.2.6. All right, so I'm just going through all the information. I'm actually studying to take the Module 4 exam. So I'm going through the information, trying to pull out any important information, make notes, so that the next time I go through the study guide, I can just focus on those areas. All right, so let's talk about the integrated product and process development, 4.2.6. The integrated product and process development evolved in industry as an outgrowth of efforts such as concurrent engineering improves customer satisfaction and competitiveness. All right, let's see, where do I have highlighted? All right, so so the integrated product process development. The integrated product teams shall be applied throughout the acquisition process. Let's see what it says. The IPPD, integrated product and process teams, facilities, meeting cost and performance objectives from product concept through production, including field support. One of the key IPPD tenets is multidisciplinary teamwork through integrated product teams. All right, so integrated product and process development is done through integrated product teams. I'm trying to make sense of this thing. So on page 427, now it says that there are 3 different types of IPTs: the overarching integrated product team, integrated product team, and the working level integrated product team. Let's see. IPPD process is implemented in the DoD using these 3 different IPTs, integrated product teams. All acquisition category, ACAT 1 Delta and 1 AM. Remember, 1 Delta means it's a DoD level program. IAM is a DoD level automation program. 1 AM. So all acquisition category 1 Delta and 1 AM programs will have an overarching integrated product team to provide assistance and oversight. All right, where's my pencil? So I can keep track of the differences. All right, so acquisition category 1 Delta and 1 AM has OIPT, overarching. All right, let's see what else. The program manager or designee, in collaboration with the Office of the Secretary of Defense, action officer from the Office of the OIPT leader, shall collaborate and form co-leads on an integrated product team. The IIPT coordinates the activities of the working level product teams and reviews issues they do not address. The IIPT may also resolve issues or conflicts that may arise among the working. All right, so they got the working level, working group, working level integrated product teams, then the integrating, so that means it's a higher level of integrated product team that pulls all the working level integrated product teams together to resolve issues. Let's see, the third paragraph says the program manager and the OSD action officer, assisted by the IIPT, should develop a working level integrated product team structure and propose the structure to the overarching integrated product team. WIPT should meet as required to help the program manager plan program structure. All right, so the three different levels of IPTs in order: overarching integrated product team, integrating integrated product teams, and working level integrated product teams. All right, let's see what it says again. All right, so I'm gonna pause right here. All right, on the bottom of page 427, it says the three bullets. The program manager is in charge of the program. The working level integrated product teams are advisory bodies to the program manager, and direct communication between the program office and all levels in the acquisition, oversight, and review process is expected as a means of exchanging information and building trust. All right, summary goes over the definition again. All right, so let's go continuing with systems engineering on page 429. You got a bunch of definitions there. So I'm going to take it over to page 4-11 and go over some of these definitions. The technical management process. Decision analysis. So I have a check mark there that I need to look at this. All right, decision analysis activities provide the basis for evaluating and selecting alternatives when decisions need to be made. Decision analysis involves selecting the criteria for the decision and the methods to be used in conducting the analysis. For example, during system design, analysis must be conducted to help choose amongst alternatives to achieve a balanced, supportive, and robust cost and effective system design. All right, so decision analysis, they're asking you what's the purpose of a decision analysis, and it makes sense. You want to get the best alternative, the best product, the best selection to be able to do what you wanted to do, but the one that is cost effective. So you got to look at all those measures. Technical planning. Technical planning activities ensure that the systems engineering processes are applied throughout the system's life cycle. Technical assessment are activities that measure the technical progress. So you're testing as you go along, your technical assessment to ensure that, okay, yep, it's doing what it's supposed to do, or no, it's not. Then if it's not doing, what do we do? What are our alternatives? Technical management process. Requirements management on page 12, 4212 says, requirements management provides traceability back to the user-defined capability as documented through the Joint Capabilities Integration and Development System. So remember, JCIDS, when we identify what that capability gap was, and we also identify the need, what do we need? So the requirements management in that process is there also ensuring that it ties back to filling that capability gap. The program manager should institute requirements management to 1. Maintain traceability of all the requirements from capability need to document all changes to those requirements and to record the rationale to make the changes. So what are the rationale? Why were the changes made? So requirements management. Risk management, configuration management is the application of sound business. So if you notice different definitions, that tells me that I need to know the differences in the event that I see it in a multiplication type, if I say multiplication, a multiple choice type question, that I'll be able to know the difference between configuration management and requirements management. So it says configuration management is the application of sound business practices to establish and maintain consistency of a product's attributes with its requirements and product configuration information. Configuration management efforts result in a complete audit trail of decisions and design modification. So the configuration management, all the changes that are made along the way is kept track there. The requirements management is making sure that it's still being able to do what we want it to do. You also have data management on page 4213. And data management says consists of the disciplined processes and systems used to plan for, acquire, assess, manage, protect, and use data of a technical nature to support the total life cycle of the system. So all the costs and issues associated with that process. Interface management process ensures interface definition and compliance among the elements that compose the system. So make sure, can they interface with other systems? Continuously check that to ensure that it's doing what it's supposed to do. On page 4214, it talks about technical processes. All right, so what type of processes were these? That's my technical management processes, and now we're talking about technical processes on page 4214. So technical processes include stakeholder requirements definition. The requirements development process takes all inputs from the relevant stakeholders and translate the inputs into technical requirements. Requirements analysis includes the definition and refinement of system. Requirements analysis, we're refining the system and subsystems within that process. Architectural design. The architectural design process is a trade and synthesis process. It translates the output of the stakeholders' requirements, definition, and requirements processes into alternative design. Architectural design, we're looking for alternative. Implementation, still looking at the technical processes. Implementation is a process that actually yields the lowest level system, underline that, lowest level system elements in the system hierarchy. Implementation, the lowest level system elements in the hierarchy. Integration. Integration is the process of incorporating the lower level system into a higher level system. So we implement the lower level and integrate it into a higher level. So now I know too. Verification. The verification process confirms that the system meets their design to or build to specification. It answers the question, did you build it right? You build it, or did you build it correctly? Did you build it right? So you're verifying, verification, you're building, did you build it correctly? Validation, the question that is answered with validation, is it the right solution for the problem? You're validating. Is it the right solution? All right. So we got a stakeholders, requirements analysis, making sure it meets that requirement that we established in the beginning. Architectural design, we're looking to translate the output into alternatives. So architectural design, we're looking for alternatives. Implement at the lowest level system elements and integrate into a higher level system. We verify that we build it correctly, and we validate that it's doing the right thing. Transition is a process applied to move the system element to the next level in the physical architecture for the end item system. All right, so I think for this part, I'm gonna stop right here because we're already about 20 minutes. So that is the end of that section where I'm gonna stop with transition under the technical processes. All right, so I'll see you guys in another video. I'm going to continue on page 4-16 at that time with the systems of systems engineering, because I got to break the information down into smaller pieces so that it's easier to understand. Thank you, and I'll see you guys again next time. Be sure to share or subscribe. So subscribe anyway so that you can get the updates as I'm putting the new videos out. But be sure to share this YouTube page with your friends.